Hello and welcome to TrainSignal. I'm Don Jones, and this is the Multi-Table Queries lesson of the Database Administration Fundamentals course. Multi-table queries are where SQL Server really shines. This is what makes it a relational database management system. In this lesson, we'll cover the join clause, talk about performance and multi-table queries, and then look at two specific types of joins, inner joins and outer joins. So far, the queries that you've seen have been primarily from a single table, but SQL Server is a relational database system, meaning it is specifically designed to understand how different tables relate to each other. You may well have to create a query that presents a unified view of multiple related tables, and the join clause provides the means for doing so in an ad hoc query, in a view, in a stored procedure, or anywhere else. Let's walk through an example. Now, this can get complicated, so I'll try and go slowly, but make sure that you're kind of following along as we go. We're starting with three distinct tables: the customers table, the orders table, and the order items table. You'll notice that each of these has an ID. The customers table uses the cust ID column to uniquely identify each customer. The orders table has an ID column to uniquely identify each order. And the order items table has an ID column to uniquely identify each item that is part of an order. These tables are related to one another. The orders table duplicates the cust ID column. It can only include those values that already appear in the cust ID column of the customers table. This creates a one-to-n or one-to-many relationship, meaning one item in the customers table can be related to many items in the orders table. In other words, each customer can place many different orders with our company. The orders table's ID column is used in the ID column of the order items table. This is also a one-to-many relationship, meaning each order can have many different order items. When you start working with multi-table queries, performance can become a real concern. Multi-table queries can involve a lot of processing in SQL Server. Having indexes built on columns that connect the tables, often an ID column or something similar, can speed things up a lot. The more tables you join in a query, the greater the processing overhead. If you start to get around 8, 9, and 10 tables in a single query, you need to start being very careful with performance. And fine-tuning these queries can be an incredibly complex art. An inner join tells SQL Server how two tables connect and returns all rows where a match is made in both tables. Here are our three example tables again on the top of the screen in blue. In the middle is the query we're executing. I need to point out a few things about the way this particular query is written. First of all, the select portion is specifying three different column names: c.name, o.date, and oi.skew. So where does the c. o. and oi. come from? Well, those are called table aliases. If you look at the from portion of the query, you'll notice it says from customers C. That means from now on I'll be able to refer to the customers column by the shorter C alias. So when I said select c.name, I meant select the name column from the customers table. So it's c. for customers table, name. I'm then executing an inner join, joining the orders table, which will be known as O. And the columns on which I'm creating that join are c.custID, so that's the cust ID column from the customers table, equals cust ID from the O, or orders table. So this is what that looks like. I'm connecting those two columns in those two tables, and that tells SQL Server, hey, in the orders table, the cust ID column will only contain values from the cust ID column of the customers table. That's how I'm referencing back to the customer that placed the order. I'm then creating a second join using inner join again. This time I'm inner joining the order items table, which I'll refer to as OI for order items. And I'm connecting it to the ID column of the orders table. In other words, I'm doing this. I'm saying that the ID column in the order items table corresponds to the ID column in the orders table. That's how I'm referencing back so I know which order items go with each order. I'm then adding a where clause. I only want those rows where the city column of the customers table is either Las Vegas or Denver. And the result is shown in green at the bottom of the screen. I've only gotten those rows from the customers table where the city says Las Vegas or Denver. That allows the customer IDs 17 and 22 to carry over to the orders table, and so I get the two orders that those customers have placed. That ID column, 97 and 98, allows me to retrieve the items that those customers ordered. And so my final result set can include the customer's name, the date they placed their order, and the SKU that they ordered from our company. The select portion of my query determines which columns were included in my results: the name from the customers table, the date from the orders table, and the SKU from the order items table. Let's see an inner join in action by going over to SQL Server Management Studio and running a query. Successfully reading these queries can require a little bit of practice. For example, I start with select p.firstname, p.lastname. Well, what's the p stand for? That requires me to skip ahead a bit. P is the alias I have assigned to the person.person table. Okay, let's stop right there and open up person.person. Take a look at its columns. So it does have a first name and a last name, and I'm selecting those columns. Next, I'm getting e.hiredate and e.vacationhours. E is the alias I have created for the human resources.employee table. So let's check that out as well. Here it is, and it looks like I do have a hire date, and it looks like I do have a vacation hours. So I've got all the information I want. I need to decide how those two relate to each other. And what I found is that the employees table has a business entity ID, and that corresponds to the business entity ID of the person table. So I'm simply telling SQL Server, look, these two columns in these two tables mean the same thing. This is how they relate or attach to each other. So if I execute, I'll not only get the first name and last name from the employees column, but I'll get their hire date and the number of vacation hours that they have. So this is a really, really useful technique. And obviously, you can get very, very complicated connecting these things to one another. You can have more and more and more joins to successively relate more and more and more tables. Now, there's no reason you have to build these things manually if you don't want to. Up here in the query menu, let's see if I can find my designer. I just tell it what tables I want to work with. Let's see, we want to grab, person should be in here somewhere. There's person, so we'll add that. And then we also wanted employee from human resources. We'll add that. And it knows that the two are connected to one another. It's actually got a line drawn between them, and it's telling me in this little tooltip pop-up that they're joined on the business entity ID. So I can say I want the first name and the last name. Let's go ahead and grab the title and their middle name too. What the heck? And we want to get their job title, birth date, hire date, and their vacation and sick hours. And it constructs the entire query down here for me. I can select all of it and just copy it to the clipboard, or hit OK to bring that over into my query editor window. So I pasted that in kind of in the middle of the other one. So I'm just going to paste in the whole revised query there. There we go. So I can just run this particular query by itself, and I'll get all of that data. So it's nice to kind of have that little visual designer, and especially as you start working with 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tables in your joins, and that can make it a little bit easier to keep track of what relates to what and how. So in an inner join, you get all rows from each joined table that match. An outer join works slightly differently. It returns all rows in one table, even if there are no matching rows in the other table, while also returning matching rows from the other table. You can use the left or right keyword to indicate which table should return all, even non-matching, rows. Or use full to return all rows from both tables, even when there are no matches. Rows with no match will contain null in the other table's columns. For example, we're back to our 3 tables, customers, orders, and order items. Take a look at the query in the middle of the screen. I'm attempting to select c.name and o.date. That's the name column from the customers table and the date column from the orders table. I'm selecting those from customers, which I've aliased as C, and I'm performing a left outer join on the orders table, which I've aliased as O. And I'm joining them on the customer's cust ID column and the orders cust ID column. Look at my join statement, left outer join. On the left side is my customers table, so I will receive all rows from the customers table, even if there is no corresponding row in the orders table. Had I done a right outer join, I would have received all rows in my orders table, even if there was no corresponding row in the customers table. So the result is that I'm getting all of the rows from the customers table, and I can see here the customer's name. There's the date from the orders column, and look at the very last line of my results. John, he's customer number 57. He doesn't have any orders in the orders table. He's still included in the results because I did a left outer join. So his name shows up in the name column from the customers table, but since he didn't place any orders, the date column from the orders table contains the value null. Let's hop over into SQL Management Studio and take a look at an outer join. So this is an example of an outer join, specifically a left outer join, which means I want all rows from the left side and all of those rows on the right side which match. Sometimes it's a little easier if you reformat this way, because now it's a little bit more obvious that this is on the left side of the join and this is on the right side. So I have asked for the product ID, name, and order quantity from the product and work order tables, and you can see when I get near the bottom that there are some products that have no work orders, and so the order quantity column gets null in those ones. So I've got a whole bunch of nulls at the bottom. This is selecting all the products, whether there's a match in work orders or not. And when there isn't a match in work orders, then the columns that were selected from work orders get filled with a null value. Now I'm going to select this before going up to Query and selecting Design Query in Editor, because by selecting that text, I pre-populate the graphical editor with my existing query. So here it is down here exactly as I've written it. I can add more columns, so let's grab a few more. I can right-click. You notice this little icon, how it shows a box on the left-hand side? That tells me it's a left outer join. And if I right-click here, I can see I'm selecting all rows from P, which is my product table, and I'm not necessarily selecting all rows from WO. I could. And now it's changed into a full box. So I'm going to get everything from both rows, both tables, whether they have a match in the other table or not. And if they don't match, then the non-matching stuff will have the nulls filled in, just like you saw. So again, that query designer is kind of a neat way of visually troubleshooting and visually designing your queries until you become more familiar with the actual syntax. In this lesson, we've started looking at what makes SQL Server a relational database management system. We looked at the join clause, talked about performance concerns with multi-table queries, and looked at examples of both inner joins and outer joins.